the unit Understanding Capacity. In this unit, you will understand the factors affecting capacity. This unit comprises of 3 modules and a final review section that invites you to reflect on what you have learned. By the end of this unit, student will be able to define capacity, classify capacity, state the factors affecting capacity, review examples from the garment industry to illustrate the concepts. The first module defines capacity and focuses on the significance of capacity calculation. Capacity refers to the productive capability potential of a plant, machine or work center in a given period of time. Capacity is created from availability of resources like machine, time, space, facilities, etc. Capacity measurement. When measuring capacity, use minutes not pieces, as different products will have different SAM values. For example, 12 minutes are taken by t-shirt, 20 minutes by pair of jeans and 9 minutes for a skirt. So, capacity measurement is done in units of output, that is number of garments produced, or in terms of input, that is number of hours or days. Basic capacity calculation is shown here. Let's assume that a company works for 8 hours per day or 480 minutes. Number of operators per team is 10. So, capacity is 10 into 480, that is 4800 minutes per day. It is the maximum capacity of the plant. If the standard minutes of the t-shirt A is 12, then target output for the line is 4800 divided by 12, that is 400 pieces per day. Capacity calculation with style change. Style changes will normally mean that during the initial period efficiency was lower. Planning must take this into account. This is done by applying a learning curve or startup allowance. It may be that we expect team 1 to reach 100% efficiency on a knit t-shirt style. They will need some time to build up their skill and therefore efficiency. The first few days or weeks output will be lower while machines are changed, operators develop new skills, the line is balanced and the quality standards are achieved. This is called as startup allowance or learning curve. A company at 100% efficiency output produces 400 pieces per day, but for example a 6-day allowance might look like this. Day 1 the efficiency is 50%, then increases to 60%, 70, 80, 90, 95 and finally normal efficiency achieved on day 7. The graph refers to the relationship between the actual output that is produced with the installed equipment and the potential output that could be produced with it if the capacity was fully used during the style change. The startup loss can also be seen here. Capacity inventory. For calculation, we can prepare a table which is linked to the computer. It will tell how long an order will take to complete according to the production units available. Such a table is often called capacity inventory. Lead time. Lead time is the time period between the placement of an order and shipment of the completed order to the customer. A short manufacturing lead time is a competitive advantage to a company. Many customers want the delivery of their product to be as soon as possible from the placement of the order. Lead time consists of waiting time before and after the actual manufacturing and throughput time. The second module examines the factors affecting capacity. Capacity can be calculated for different areas depending on the requirement like plant capacity, section capacity, line capacity, individual operation capacity. Factors which affect capacity of a plant, section, line or individual are machinist work, attendance, utilization, average performance and unexpected problems. For example, factors affecting production capacity for cutting department are type of laying up machine, cutting machinery allocated, skill of cutter involved, depth of the lay, thickness of the fabric, cutting accuracy required and presence or absence of vacuum system, etc. The major reasons for low capacity of Indian companies are inconsistency of export orders, frequent breakdown of machinery, Average age of the machinery used by Indian firm is more than 10 years. Hence, chances of breakdown are more. Availability of electricians, technicians is also an issue which hampers production in case of machine breakdown. Then inconsistent power supply, inconsistent raw material supply, labor absenteeism, equipment type configuration and uses, the skill size, versatility and productivity of labor force. Capacity can be increased in number of ways such as better use of available resources, changing the resources, breaks, multiple shifts or by addition of equipments or operator. Capacity planning is concerned with defining short-term and long-term capacity need of an organization and determining how these needs will be satisfied. Capacity planning includes long-term strategies and short-term strategies. Long-term strategies are made for multiple product manufacturing, phasing in capacity and phasing out capacity. On the other hand, short-term strategies are made for dealing with inventories, backlog, employment level, hiring and firing, employee training, workforce utilization, subcontracting, process design and for maintenance. Plant Performance Index shows the variation of percentage between the planned work and the actual work done. The final module explains how capacity is classified. Capacity can be of different types such as maximum capacity, potential capacity, committed capacity, available capacity, required capacity and excess capacity. Maximum capacity, the total hours available under normal conditions in a given period of time. Potential capacity, maximum capacity adjusted for efficiency. Committed capacity, total hours previously allocated for production during a certain period of time. Available capacity is the difference between the potential and committed capacity over a period of time. Required capacity, standard allowed hours necessary to produce a specified volume in a certain period of time. Excess capacity is a difference between a potential capacity and the required capacity. Capacity is calculated as number of machines or workers into number of shifts into utilization into efficiency into performance. Read the scenario and let's answer these questions. A small apparel contract swing business employs 180 operators who work for 40 hours a week, 5 days a week. The plant's absenteeism is 5%. Operators do the job for which they are trained and equipped for 80% of the time. An average performance is 90 BSI instead of 100 BSI. All these factors reduce the output. A customer brought an order for 24,000 pieces of style A that needs a 2-week turnaround. SAM per garment is 20 minutes. A plant has an appropriate equipment and skill to make the style. The plant also has a committed capacity of 1500 standard hours for 2-week period. Now we will calculate the maximum capacity of the plant in standard minutes for 2 weeks. Maximum capacity will be number of operators into hours per week into number of week, that is 180 into 40 into 2, that is maximum capacity is 7002 hours per week or 14,400 for 2 weeks. To calculate the potential capacity of plant in standard minutes for 2 weeks, we need to use the formula potential capacity is equals to maximum capacity into utilization into performance into attendance. 14,400 into 80 upon 100 into 90 upon 100 into 95 upon 100. Potential capacity is 4925 hours per week or 9,850 for 2 weeks. To calculate the plant throughput time for the order, the formula is SAM of the garment into order quantity divided by 100, that is 20 into 24,000 divided by 60. Throughput time of an order is 8,000 hours. Is this adequate potential capacity to accept the order? Yes, because total potential capacity minus committed capacity is 9850 minus 1500, it is 8350. Therefore, enough capacity is available to accept the order. What factors should be considered in deciding whether to accept the order or not? These factors should be considered in deciding whether to accept the order or not. Analysis of the order on the basis of quantitative production capacity. Also analysis of order on the basis of quality specifications of the product like raw material, production equipment and tool, production personnel. Capacity utilization. Capacity utilization is a metric used to measure the rate at which potential output levels are being met or used. Displayed as a percentage, capacity utilization levels give insight into the overall slack in the economy or a firm at a given point of time and refers to the extent to which an enterprise or a nation actually uses its installed productive capacity. For example, the details of produced minutes, capacity and capacity utilization of a company. Factory XYZ has 400 operators and they work at 65% efficiency. The factory runs 24 days in a month, 8 hours each day. The factory made 2 lakh pieces of 12 minutes each in the last month. Produced minute is 2 lakh into 12, that is 24 lakh minutes. Capacity is equals to 400 into 0.65 into 24 into 480, that is 29 lakh 95,200 minutes. Capacity utilization, that is 24 lakh minutes divided by 29 lakh 95,200 minutes, that is 80%. You have now reached the end of this unit. To summarize, in this unit you have reviewed the definitions of capacity, the significance of capacity calculation. You have also learnt how capacity is classified and reviewed the factors affecting capacity with examples from garment industry. Thank you.